So we're working on property of exponents. This time we're talking about raising a power to a power. So when we're doing that, we want to multiply our exponents. And evaluate the coefficients. Because you're also raising your coefficients to that power. So as the form for that, so that's x to the m raised to the n is the same as saying x to the m times n. So we're always multiplying those exponents. The zero exponent says that x to the 0 is equal to 1. So what that means is anything, any number, any variable raised to the power of 0 equals 1. So that could be 1 million to the 0 power, just equal to 1. A, B, C, D, all raised to the 0 power, just equal to 1. So any number, any variable raised to the 0 power is equal to 1. A negative exponent. So if you have x to the negative n over 1, if it's in your numerator, to make that exponent positive, we just move it to the denominator. We don't change anything else, we just move where it is. If it's negative in the denominator, x to the negative n, then we just move it into our numerator to make it positive. So all we're doing is moving things back and forth. So let's look at some examples of this. So we're going to first start with just the negative exponents, and then we'll deal with the power property. So looking at number 1, we are multiplying here. So when we multiply, we are adding our exponents. So I first want to multiply my coefficients. So 2 times 3 gives me 6. Then I'm going to add my exponents. So I have 3 plus 4, so I have x to the 7th. I have negative 2 plus negative 3, so that gives me y to the negative 5th. Now, I need my answer to only have positive exponents, so we're going to go ahead and take this whole y to the negative 5th. And we have this over 1. We're going to move that into our denominator. So our final answer is going to be 6x to the 7th, that coefficient doesn't change, over y to the 5th. And that is our final answer. So all we're doing is moving it around a little bit to make sure that it's positive. So again, exponents need to be positive in your final answer. So let's look at number 2. Again, we're multiplying, so we're adding our exponents. So I'm taking 3, I'm multiplying it times 2. That gives me 6. I have negative 3 plus negative 3 with my x's, so that gives me x to the negative 6th. I have 2 plus negative 4 for my y, so that gives me y to the negative 2nd. I have 2 variables with negative exponents. So x and y both have negative exponents. So they are both going to move to our denominator. So our final answer is going to be 6 over x to the 6th, y to the 2nd. So we're just moving where they are. So let's go ahead and look at division now. So division I'm going to do a little bit differently. I prefer to move them first so that they start all as positive and then I can deal with them. So first thing I'm going to do though is I'm going to simplify my coefficients. So 2 over 4, we can divide both of those by 2, so I get 1 over 2. Now I'm going to look to move my variables first. So I see x to the negative 2nd. I'm going to move that into our denominator. I see y to the negative fifth. I'm going to move that into my numerator. So y to the third stays as it is, because that was positive, it stays. X to the second stays as it is, because that was positive to begin with. Now I'm moving that x to the negative 2 from the numerator here down to my denominator, so it becomes positive. I'm moving this y to the negative fifth into my numerator, so it becomes positive. When I move these, I am now multiplying those terms. So I have 3 times 5 is 8, so I have y to the 8th over x squared times x squared. Again, we're adding exponents, so we have 2x to the 4th. So our final answer is y to the 8th over 2x to the 4th. So again, I know that gets a little bit complicated. We can also think of it as another way of subtracting if you'd like, so I can show you guys that. So if I'm just thinking of 2x to the negative second, y to the third, over 4x squared, y to the negative fifth. So if I just want to think about subtracting, I'm going to say x to the negative 2 minus 2, right? Because division, we subtract our exponents. So I'm just going to talk about the exponents here. So that would give me x to the negative 4th. For my y's, I have y to the third minus negative 5. So that would give me y to the 8th. So right now I'd simplify my 2 and my 4. So I'd have 1 over 2, x to the negative 4th, y to the 8th. We would keep it all in the numerator to start. Then I would move down my x to the negative 4th to the denominator. So you'd end up with your y to the 8th over 2x to the 4th. So whichever way you find it to make more sense, you can absolutely do. For me personally, I prefer the first method. Either way, you're doing the same exact thing. So now let's go ahead and add in our power rule. So all we're doing is multiplying our exponents. So here we have 5 times 3. So this is just x to the 15th. The coefficient is 1, so we don't have to do anything. Final answer, x to the 15th. Number 5, here we have a coefficient. So our exponent with our coefficients is always 1. So I'm saying 1 times 3, so I have 2 to the third. Y, 5 times 3 is y to the 15th. Now I'm just going to go ahead and evaluate that coefficient. So that means I'm just going to say 2 to the third is just 8. So my answer is 8y to the 15th. Number 6, this negative 2 is on the outside of our parentheses, so it is not being raised to the 5th. So it just comes down as negative 2. My exponents with x and y are both 1. So we're going to say 1 times 5 is 5. And again, 1 times 5 is 5. So our final answer is negative 2, x to the 5th, y to the 5th. All right. Number 7. We're going to want to follow order of operations here first. So we're going to want to go ahead and do our different color. This exponent first. Then we'll do our multiplication. So 1 times 2 is 2, so we have 2 squared. X to the 2 times 2 is 4. Y to the 1 times 2 is 2. So I'm going to evaluate this before I talk about multiplying. So then we have 4x to the 4th, y to the 2nd. Now I'm going to go ahead and bring this down and multiply it. So we have times 3x squared y to the 4th. So now we multiply our coefficients. So 4 times 3 is 12. Add our exponents. So 4 plus 2 is 6. And again, we add our y exponents. So 2 plus 4 is 6. So our final answer is 12x to the 6th, y to the 6th. All right, let's go ahead and look at number 8. So number 8, we're going to have to raise both of these. So we have this set of parentheses being raised to the 2nd. And this set of parentheses is being raised to the 3rd. So first thing I'm doing, this -3 has an exponent of 1. So we are saying -3, make sure you put that in parentheses, squared. For x's, 1 times 2 is 2. Y's are 2 times 2 is 4. For our z, 4 times 2 is 8. Now we're going to go ahead and raise 2xy to the 3rd power. These all have exponents of 1. So I end up with 2 to the 3rd, x to the 3rd, y to the 3rd. Now I'm just going to evaluate those coefficients. So I have 9x squared, y to the 4th, z to the 8th, times 2 to the 3rd is 8, x to the 3rd, y to the 3rd. Now I'm just going to multiply these two. Probably keep this a different color. So multiply our coefficients, add our exponents. So 9 times 8 is 72, x to the 5th, y to the 7th, and then z to the 8th just stays as is because there's no z to add it to from the 2nd term. All right, number 9. So 9, we follow order of operations every single time. So at this one, we're going to have to do this multiplication first, and then we'll raise it to the 2nd power. So because we always want to do inside our parentheses first. So we have 4 times -2 is -8. We're keeping it in parentheses. 2 plus 5, so x to the 7th. 1 plus 4, so x to the 5th. And we are raising this all to the 2nd power. So we are saying -8 squared. 7 times 2 is 14. 5 times 2, so y to the 10th. -8 squared gives us 64. So we have 64 x to the 14th, y to the 10th. Final answer. Okay, number 10. So we're going to have to do our exponents first, then we'll divide. So I am doing this top part here first. And then I will do this bottom part here. So the denominator. So we'll do our numerator first, then our denominator. So coefficient is 1, so we don't have to change anything with our coefficients. So 2 times 2 is 4. 3 times 2 is 6. So we have a to the 4th, b to the 6th over 4 times 3 is 12. 1 times 3 is 3. Don't forget that there's a 1 there. Now all we have to do is our division, which means we subtract our exponents. So 12 minus 4 is 8. And it started larger in our denominator. So we have a to the 8th. 6 minus 3 is 3. It was larger in our numerator, so b to the 3rd stays in our numerator. So our final answer, b to the 3rd over b to the 8th. Number 11. So again, because we have powers raised, then division, so we have to follow those order of operations. So here is our first step. Here is our second step. So automatically, I see that this whole entire piece is being raised to 0. So this whole entire numerator is being raised to 0. So this entire thing is gone, and we are just left with the number 1. So our numerator is just 1. Now in our denominator, I have negative 3 squared, a squared, b squared. All I'm going to do is simplify that negative 3 squared, so it becomes 1 over 9a squared b squared. And that's our final answer there. Okay, number 9. Again, now I see some negative exponents, but we're still just going to do the same thing. There are a few different ways to do this, but I just want to keep it consistent. So we're not going to move anything until after we raise our powers. So we're going to go ahead, and with our numerator, we are saying negative 2. We are multiplying exponents, so 1 times negative 2 is negative 2. We have a to the 2 times negative 2 is negative 4. We have b, 1 times negative 2 is negative 2. In our denominator, we are raising to the negative third. So we are saying 3 to the negative third, a to the negative third, and b to the negative third. So now I am going to move everything that is negative exponents in my numerator, which is everything, to our denominator. So negative 2 to the negative 2. So your negative 2 stays the same, that coefficient, but our exponent now changes to a positive 2. A to the negative fourth becomes a to the fourth in the denominator. B to the negative second becomes b squared in the denominator. So all of those exponents becomes positive. So now we're going to move everything from our denominator that had a negative exponent into the numerator. So we have 3 to the third. We have a to the third. And we have b to the third. Now we're going to go ahead and simplify those coefficients. So I have 3 to the third is 27. A to the third, b to the third stays the same. Negative 2 squared gives me 4. A to the fourth, b squared. Now we're going to do our simplifying, our division. 27 over 4 can't be changed. 4 minus 3 is 1, and a was larger in the denominator, so it stays in the denominator. 3 minus 2 is 1. It was larger in the numerator, so it stays in the numerator. So our answer here is going to be 27b over 4a. All right, number 13. So we have negative 4, a to the third b being raised to the negative second. So we're going to start there. Then we have a squared b being raised to the third, so that'll be our second step, and then we'll move things around. So this numerator becomes negative 4 to the negative second, a to the negative sixth, b to the negative 2, over, we're going to go ahead and multiply 2 times 3, so we have a to the sixth, 1 times 3, b to the third. Should be a different color. So now I'm going to move anything that's negative in my numerator to my denominator, anything negative in my denominator to my numerator. So, but in this case, nothing in my denominator is moving. I'm only moving things from my numerator into my denominator. So I'm keeping this a to the sixth, b to the third the same, and I'm bringing down, so I'm going to have to multiply the negative 4 to the second, a now to the positive 6, b to the second. And since I no longer have anything in my numerator, I need something there. So I'm just going to put a 1 there. So anytime your numerator is completely gone, you need to have a 1. So now I'm just going to go ahead and simplify down here. I should have made this green because this came from the top. So this 1 in the numerator stays. A to the 6, b to the third doesn't change yet. Times negative 4 squared will give me positive 16. A to the 6, b squared. Now we're going to multiply those two pieces of our denominators together. So 16 times 1 is 16. A to the 6 times a to the 6 gives us a to the 12th. B to the third times b to the second. Add those exponents so we get b to the 5th. So our final answer is 1 over 16a to the 12th, b to the 5th. All right, and the last example we're going to look at today, 5x squared y over 4x to the third y, all being raised to the negative second. So this 5x squared y is actually going to be nice for us. It's just going to stay the same. So we have 5x squared y over, I'm going to raise this 4 to the negative second. I'm multiplying 3 times negative 2 to give me negative 6. And I'm multiplying y times negative 2 to give me negative 2. So now I keep 5x squared y the same. There's no negative exponents there. I'm moving everything in my denominator that has a negative exponent to my numerator. So I end up with 4 squared, x to the positive 6th, y to the second. I now have nothing in my denominator, so you can put a 1, but you do not need it. You need it when it's in your numerator, don't need it when it's in your denominator. So we keep 5x squared y the same for now. 4 squared gives us 16. So now we'll go ahead and multiply. 5 times 16 gives me 80. Combine our x squared, x to the 6th gives us x to the 8th. Y to the first times y squared gives me y to the third. So our final answer is 80 x to the 8th, y to the third.